Hi guys, in today's video we're going to look at how we use arrows in reaction mechanisms, bond fission, looking at homolytic fission and heterolytic fission, bond formation, an exam style question, and finally a summary.
So we're going to begin by discussing how we can use curly arrows to represent the movement of electrons in our reaction mechanisms. Well, as I just mentioned, curly arrows are indeed used to show the movement of electrons, and each line of our arrow head represents the movement of one electron from our covalent bond. So our arrows can start on either a bond, a lone pair of electrons, or the negative charge of our ion, and they finish on the atom they're moving to, showing the movement of electrons. So before we have a look at how we use these arrows and the different types of arrows we use, let's take a look at the term bond fission. Bond fission is the breaking of our chemical bonds. We can classify our bond fission of our covalent bonds into two categories. Those are homolytic and heterolytic. And we can break down those terms, where homo comes from the Greek to mean equal, so the bond splits equally, and lytic comes from the Greek term lysis, which means breaking down, representing the splitting of our chemical bond. And the hetero and heterolytic means other or different, and the bond is split unequally. So let's take a look then at homolytic fission. Well, as I mentioned, homolytic fission is when our chemical bond breaks equally and each electron goes to a different atom in the bond. As you can see here, the way we represent this is using half-headed curly arrows to show that each of the atoms in our bond, which in this case are X and Y, are receiving one of the electrons from the pair in our covalent bond. Now, this type of bond fission results in the formation of free radicals. We represent free radicals with a dot like this, and they're highly reactive species as they possess one unpaired electron. So let's take a look at an example of a reaction. We're going to look at the homolytic fission of a molecule of bromine. If I go ahead and write out our molecule of bromine as such, the bond is going to split homolytically, which we know will require two single-headed arrows. So one electron will go to this bromine atom and one to this bromine atom. And what we end up with are two bromine free radicals represented by that dot. So now I've looked at homolytic fission. Look at heterolytic fission. Unlike homolytic fission, in heterolytic fission, when our covalent bond breaks, both of the electrons in the pair go to the same atom in the bond. And rather than forming free radicals, we form ions. So here you can see we have a double-headed arrow representing the movement of both of the electrons towards one atom. And you can see that our arrow originates at our bond. So we formed a positive ion, our cation, and a negative ion, our anion, and it's our anion that has received the pair of electrons in the bond.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.